The electrical three-phase voltage coming into a facility will be stepped down from the utility feed by a distribution transformer. At the entrance, a utility power meter measures the incoming electricity. The customer owns and maintains all equipment downstream from the meter. Note that in this diagram, the three phases are represented by a single line. The power is fed to the main distribution panel, which may further transform the voltages to suit the specific power needs of office equipment or other mechanical devices. This equipment contains protection circuitry such as fuses, circuit breakers, and switches to prevent failures from bringing down the entire system, or to allow circuits to be switched off for maintenance. The main distribution panel connects to an automatic transfer switch, or ATS, which looks for utility feed disruptions and power quality that is outside of specified limits. The power feed goes on to the uninterrupted power supply, which always powers the load either from the utility, an internal power source such as batteries, or the backup generator. The UPS may also provide backup power to mechanical loads, such as cooling equipment that needs to continue operating when the utility power fails. This entire critical load is backed up from generators that are connected via the ATS. If the utility field is interrupted, the ATS will send a signal to start the generators. It can take some time for the engines to power up. During this time, the UPS continues to use battery power to provide temporary power to critical equipment. Once the generators are fully operating and the ATS gear senses power with correct frequency and voltage, the automatic transfer switch connects the generator to the circuit, allowing the UPS battery to come offline and charge in preparation of the next event. When the utility feed comes back on, the ATS communicates back to the generators and allows them to go offline. This is an example of 1N redundancy, with a small percentage of redundancy to individual parts. Tier 3 and Tier 4 data centers require 2N redundancy, which is a mirrored system with two separate points of independent distribution, ultimately feeding two separate rack PDUs, and an AB feed that typically supplies power to A and B power supplies within the IT device for complete redundancy of power.